So let's start moving on to our three-dimensional pictures, okay? So these were what we called our models when we were talking about different types of formulas and structures. So why do we care? Because the structure determines the properties. So properties of my molecule, of whatever I'm looking at, depend on what the structure is. So if I don't know what the structure is, it's going to be hard for me to understand why a certain molecule behaves the way it is. So what do we talk about when we talk about structure? First, that is the skeletal arrangement. Remember, this is our first step in drawing our Lewis structure, is to write the skeletal arrangement. The second is the kind of bonding. We can get that from the formula sometimes. Is it ionic? Is it covalent? Is it polar covalent? Pure covalent? So what kind of bonding are we doing? And then the shape. Okay? This is the part we're going to talk about now, is the shape. And we're going to talk about the three-dimensional shape. So bonding theory, that Lewis theory, is going to allow us to also predict the shapes of our molecules. So to be able to do this part of this chapter, to be able to do the shapes, three-dimensional, you have to be able to do the Lewis structures. You can't do this part unless you can draw a Lewis structure. Okay? So everything that we learned with our Lewis theory is going to help us to do our shapes. So when we talk about molecular geometry, when we talk about the shapes and the geometry, the shape of my molecule, how are we going to think about this? So remember, molecules are three-dimensional. They're actual physical things in space. So the shapes that we want to refer to also need to be three-dimensional shapes. So we're going to use geometric figures to represent the shapes. So we're going to use real shapes that you're familiar with. So we'll talk about, instead of a circle, a sphere. We're going to talk about, instead of a triangle, a pyramid. So we're going to talk about three-dimensional shapes. So when we talk about these three-dimensional shapes, the corners of that shape is going to be the surrounding atoms, and in the middle, the center of that shape, is where the central atom is going to be. So say I had a cube. Okay? So say I had a cube. One of my shapes would be where my central atom is in the middle, and then on the corners of my box would be the attached molecules, or atoms. Okay? So this would be one of the shapes. The central guy is in the middle of whatever the shape is, and then whatever he's attached by, whatever this is attached to the central atom, is going to be on the corners of whatever shape we talk about. We don't have a box shape per se. I just kind of draw this one to show you. It is one way to look at one of our shapes, but I'll show you other ways to think about it. Besides just the shapes, we're also going to have certain angles. So what would be the angle between this guy and like this guy? This guy and maybe my central guy. What are those angles? And those are going to be called bond angles. Okay, so these are going to be called bond angles. So why is Lewis theory? So Lewis theory is going to help us to predict these shapes. How so? Because Lewis theory predicts the regions of electrons. So remember, when we draw my Lewis dot picture, I know where all the electrons are located, because I'm placing the shared electrons between the nuclei. These are my bonds. Okay? And I place unshared electrons on a single nuclei. So remember, I've got my bonding pair electrons and my lone pair electrons. So when I draw my Lewis structure, I know where my electrons are. So this general idea of where all these electrons are can be extended and help us to predict the shapes. Because one thing I have to realize is that these regions are electrons. And remember, it doesn't matter if they're in a bond or if they're a lone pair, what do electrons want to do? They're all negative, and negatives don't want to be near other negatives. So all of these electrons should repel each other. So if I keep in mind the fact that they're all going to want to repel each other, it's going to help me to be able to understand why my molecule takes the shape it does. Okay? So this will help me to be able to predict that shape. All right, so we're going to have a theory that takes this into account and help us be able to predict what all my shapes are gonna be. So in the next lecture, we're going to move into what this theory is called.